we're going to add and subtract radicals. Believe it or not, we are. So before we do that, we've got to kind of get to an idea of what is a like radical. Hang on a second, see if we can write with something here. All right, what's a like radical? Because we have to talk about like radicals. Like radicals, yes or no, doesn't matter, but we got to work with them anyway. But I'm sorry, that's a bad joke. Uh, what are like radicals? We'll talk about that, and then after that, we'll talk about addition and subtraction of radicals. All right, so let's take a step back and go back to a couple chapters ago, talking about like terms. Like terms are terms that have exactly the same variables to exactly the same powers. Something like x squared and x squared. Something like xy and 3xy. These pairs are like radicals, or sorry, like terms. These are like terms because they have exactly the same variables and exactly the same powers. Exactly the same variables and exactly the same powers. Doesn't matter there's a 3 in front of it. It just, the important thing is that there's a x to the first, y to the first. These are like terms. Like radicals have exactly the same index and exactly the same radicand. Index is right there, kind of the key to the house if we talk about the square root house. Radicand is right in there, whatever's inside here. So, let's see, square root of 2 and square root of 2, like radicals because they've got the same index, same square root, same key to get inside the house, same radicand, same stuff inside the house. Square root, let's see, 2 square root of 5 and 5 square root 5 are like radicals because they have, as far as the radicals go, same index, same radicand, same key to get inside the house, same stuff inside the house. So these would be like radicals, and these could be added up or subtracted. These could be added up or subtracted because they are like radicals. These are like terms, could be added up or subtracted. These are like terms because they've got the same variable and the same power. These could be added up or subtracted. So there's the idea of like radicals. We've got to have the same index and the same radicand. So let's take a look at these. Here's some like radicals. Like radicals or not? Like radicals, yes. Same index, same radicand. Same index, same radicand. Inside the house is the same. Key is the same. Inside the house is the same. Key is the same. Index and radicand, same. Unlike radicals, square root of 2, they're both a square root, but this is a square root of 2, square root of 3. Nope, not like radicals. Not like radicals because this has an x in it. These should have square root houses over, or roofs over their house here. Not like radicals because this is a square root of 22y. This is a cube root of 22y. Even in spite of the fact that the 22y is the same, the square and the 2 say that they are not like radicals. All right. So we know what a like radical is and an unlike radical is. So these are like radicals, and we're going to move forward with adding and subtracting them. And how do we do that? It's the same idea as working with like terms. If I had 2x and I had 5x and I wanted to add them, could I add them? Yep, they're like terms, so I can add them by saying 2 plus 5 gives me 7x. Same idea holds true for radicals. If I've got a square root of 6 and a square root of 6, I got 2 square root of 6 and 5 square root of 6. Well, it's the same idea, just like we did with the 2x and the 5x if we wanted to add them up, we could add them up as 7x. Treat the square root of 6 as the x and say, well, I got 2 of them and 5 of them. I got 7 of them. When I add them up, I get 7 square root of 6. And there's the whole idea. That's the bottom line. If you know that these are like radicals, we can add them up. So let's take a look at this. 5, square root of 5 plus square root of 5. Like radicals? I love radicals. Oh, sorry. Are they like radicals? Yes, because we got the square root. We got 5. Like radicals? Yes. I've got one of them. Plus one of them gives me 1 plus 1, 2 square roots of 5. I can add them up because they're like radicals. Can I add these up? Yes, they're like radicals. Like radical, like radical, like radical. They're all the square root of 15, so I can add them all up. This would be 6 plus 3 plus 1 is 6 plus 3 is 9, 10, square root 15. Notice that just like when we're adding up the x's, x doesn't change. I got 2 x's and I got 5 x's. I add them up, I got 7x. The x doesn't change to x squared, doesn't change to 2x. The x stays the same. Square root of 6 stays as square root of 6. When we add up like radicals, square root of, how many? I got 6 square root of 15. I got 3 square root of 15. I got 1 square root of 15. Add them all up. 6 plus 3 plus 1 is 10 square root of 15. Down here. Can I add or subtract? Yes, because these are all square root of xy. So 1 minus 6 plus 4 square root of xy. We can add them all up. 1 minus 6 is negative 5 plus 4 is negative 1 square root of xy. I put that square root of that 1 kind of as dotted because we could just say that it would be negative. Square root of xy would be a little bit prettier. Both of these would be okay, but this one would be prettier. This is prettier. All right, add or subtract. Can we? 3 square root of 2 plus 7 square root of 2, yes, like radicals. So I got 3 plus 7, 10, square root 2. Like radicals? Yes, they are. I got a square root of x, square root of x. 8 minus 1, 7, square root of x. Like radicals? Yes, they are. Square root of ab, square root of ab, square root of ab. Add up the coefficients. 4 minus 2 is 2. Minus 9 is negative 7, square root of ab. And there's our answer, adding up like radicals.